Flack math! Give me some math and I'll give you some flack. Flack math!
All right, practice test 1. So exciting. So it doesn't say practice test on it because in Saxon, technically this is just a test, but we're using it as a practice test. So if it just says test 1 at the top left, that's just your practice test, okay? All right, so let's start with number 1. If the product of 12 and 60, what's the product of two numbers? Yes, Kiara?
If the product of two numbers is it's lift.
What kind of problem is that? What kind of
It's
multiplication? That's right. So if the product of 12 and 60, so there's the product of 12 and 60 is divided by the sum of 12 and 36. Divided by, we can just say this, right? Or we can say divided by, what's the sum of something? Yep, Grady?
Two numbers added together.
Yep, so 12 plus 36. Then what is the quotient? So what's the answer to this? Well, let's do everything on top. Anyone know a shortcut to multiplying 12 times 60, Grady?
You just multiply 6 times 12.
Which is 72.
And then you add a 0.
Right. So that's just 12 times 60, so 72D. I don't know. That probably doesn't work. Okay, and then what's the sum of 12 and 36? Do you know?
48.
48. All right. Okay, well, how do you divide that? Well, dirty monkeys smell bad, right?
Yeah, we do.
So D, how many times is 48 going to 72?
50.
One time. Oh, well, yeah. You're right. Then you subtract and you get 24. Bring down the 0. Dirty monkey smelled bad. And that goes in 5 times. So your final answer is 15. Did you guys get 15? All right. Wasn't that was kind of like a 3-part problem. You had to do a product and a sum, and then you had to do a quotient. So that's pretty cool. All right. Are you guys good with number 1?
Yes.
You guys think you can do that on the test? Something like that? Okay. All right. Number 2. Use the numbers 4 and 5 to illustrate the commutative property of multiplication. Hunter, what did you say?
4 times 5 equals 5 times.
That's beautiful. Okay? So on the test, it might say multiplication, it might say addition. So if it's addition, how would you use 4 and 5 to demonstrate the commutative property of addition? Yes?
4 plus 5 equals 5 plus 4.
That's right. Okay? And you don't even have to do the math. You don't have to say that is 20. You can just write it like that. That's beautiful. Number 3. Use digits and symbols to write -5 is less than +5. Okay, Kiara, how do you say -5 is less than +5?
So you write -5, and then you do like a space, and then you do 5, and then you do the like half the.
Okay, so which way is the arrow going to point?
It's gonna point the top, the like little tip.
Yeah,
The tip is gonna point to the one that's wrong.
the one that's smaller.
Yeah.
Okay, so remember, less than means left. See how the arrow points left? Don't go back to your crocodile days, okay? Say goodbye to your crocodile, your alligator. It's not which way that alligator bites anymore, okay? Your alligator got you through some tough times, but you need to say goodbye, all right? Goodbye.
Rip in peace, Jerry.
Rip in peace.
That's your name.
So your crocodile had a name? Aww.
His name.
So sweet. And now he's probably dead. Okay.
I buried him in the backyard.
You didn't eat him? Alligator's good. Actually, yes, Evie. It's wonderful. It tastes like chicken. Okay? So -5 is less than +5. We good? You good with number, what is that, 3? Okay. Left less. Remember that. The less than points left. Use words to write that guy. And so originally there were not commas in there, but do you see why commas were added? Because otherwise it would have looked like this, and that's kind of chaotic. So this will make it a lot easier if you put commas in there. Okay? How do you say this? Hunter? 14 million. Hold on, I can't write that fast. 14 million. So really, Hunter's just taking one group at a time. So he's ignoring all this and he's just looking at that number. We know how to say that number. It's 14. And then we say that comma. Well, if there's two commas, that second comma is going to be million. And then comma goes comma. All right, and then say that, Hunter.
328,000.
All right, 328,000. Like this? Is that right?
Yes.
Okay, that's right, but it could be righter. What would make that better? You guys remember?
Dash and 8.
Yeah, we're gonna put a little hyphen. So remember all the numbers between 20 and 100 that aren't 20, 30, 40, like multiples of 10, need a hyphen in between the 20-ish thing and the digit thing, right? 34 is 30-4. If you don't put that, it's not wrong, it's just better, okay? It's prettier. And then how do you say that? 735. Good job not saying it. 35, so I need a dash. Okay, does that make sense? You guys good with that? You guys think you can do that on a test?
Yes.
Awesome, awesome. Awesome sauce. Number 5. What are the next 3 numbers in the sequence? Okay, this is a little tricky. What is it doing? What's that sequence doing? Grace.
It's it wasn't minusing. It's taking away 3.
Okay, good. Good job catching yourself on the minus verb. We don't minus things.
No, but we do plus it.
You do? Ew.
We do plus it.
Right, you plus it. Plus it. Okay, so what's the next 2 numbers gonna? Is the next 2 numbers or 3 numbers? Oh, okay. Oh, you can handle it. All right, who's next? Grady.
48.
Uh-huh.
And then 45.
Uh-huh.
And then 42.
Uh-huh. Good job. So, 2 steps, recognize the pattern, figure out the pattern, and then apply the pattern. Can you guys do that?
Yeah.
All right, it's like a little puzzle. Yay. So let's write this sucker in expanded notation. How do you say 75,000 in expanded notation? All right, Evie.
70,000 plus 5,000.
Okay, so this is actually place value notation. Does it say expanded or place value? Expanded. So this is awesome, but expanded is just saying 7 what? Hunter?
Times 10,000.
Right, 7 10,000s or 7 times 10,000 plus 5 thousands. And then you don't have to say like 0 hundreds, 0 tens, and 0 ones. You can just leave it like that. Okay? Does that make sense? So place value notation, you don't need to do that, but that's awesome. If you need to do that first to get to there, that's great. But really you're just taking each non-zero digit and you're writing 7 and then basically 10,000. So you don't even know, you have to know how to say that. You're just putting a 1 in the 7th place and zeros everywhere else. 7 times 1, blah, blah, blah. 5 times 1, blah, blah, blah. Okay? So that's it. That's expanded notation. Can you guys do that? All right. Awesome. We're moving right along. What does it mean to compare in math? What does it mean to compare? Like, oh, this has like a nice little curvy thing. This looks like 2 circles. Yeah. That's not what it means to compare. Like you're comparing 2 products. The iPhone 11 has a really nice camera. No, that's not what compare means in math. What does compare mean in math, Kiara?
Comparing means when you take 2 numbers and then you
Got him?
and then you have a question, for example, like which of these two numbers is the least? Which
Right.
of these two numbers is the greatest? So you're
Yep.
basically taking the number that fits in with that.
Yeah, so that's all it means. It's not like which one's prettier, which one's taller. No. Which one's greater or less than. So I need a symbol here that will express the comparison. Grace, what is it?
It's the arrow.
Okay, which way is it going to go?
It's going to point right.
Yeah, so -6 is, if you were to see -6 and -8 on the number line, -6 is on the right side of -8. Okay? It's to the right of -8. Good? All right, don't be fooled by those negative numbers. It's like opposite day, those negative numbers. Okay, I'm going to try to scroll upside down. I'm a little nervous about it. Oop, I'm doing it. I'm doing it.
Don't mess up.
Okay. Show the subtraction problem on a number line. And really, you're just drawing a number line. And you're going to go over to 6 here. So if I go 0, 1, 2, 3, 4, 5, 6. I can put some negative numbers here if I want to. But I'm going to go over to the 6. Bloop, 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 bloop. Okay, there's my 6. And then I'm going to subtract 3. So I'm going to go bloop, bloop, bloop. So then I end up with +6 minus 3. So then I end up with 3. Isn't that confusing? I don't really like doing that on a number line. You can do it if you want to. And just draw a number line and 6 and 3 and whatever. Just as long as you tell me that it's 3, you're good. I'm kind of rebelling against this type of addition and subtraction. So, but don't tell anybody. Good thing it's not being recorded. Wait. Okay. Number 9. Use digits to write that number. So how would I read that number? So it's a little bit trickier, I think, it's not as much writing. It's a little bit trickier going the opposite direction. All right, boys in the back. You want to give this a shot? How do I write this? How do I write 3 million? We'll stop there. 3 million, comma. How do I write that? 3, comma. That's it. All right, let's do the next sentence, or next phrase. How do you say 40,000? Yes, Kiara.
0,
Right.
40, comma.
Okay, so it's got to be that 0. So it's got to be a 3-digit number unless it's that first one. Okay, and then how do you say the last one? Hunter?
7 and 2 zeros.
7 and 2 zeros. Okay? Does that make sense? You guys good? The other way you could do it is you could say 3 million. If this is confusing to you, you can write 3 million, add it to 40,000, and add that to 700. So if you add those together, what are you going to get? You're going to get that number. So if you're confused by it, then you can always do that. And you probably only have to do that once or twice, and then you're going to get it. All right, number 10. Okay, what happens when you're missing something in addition problem? How do you figure out the missing addend? Yes, Marin.
You subtract.
You subtract. At addition, when you're missing something in addition, it's always easy. You always just subtract. Okay, so we're going to go 12.00 minus 5.5. Okay, and you can put a 0 in there just to whenever you're subtracting with decimals, it's always nice to put zeros in the empty spaces. Yes, did you get an answer? Hunter, what'd you get?
6.50.
All right. Good job. So 6.5, you can say 6.50 or 50, or you can say 6 and 50 what? Cents or hundredths?
Oh yeah.
Because a cent is a hundredth, right? We haven't really talked about decimals yet. Have we talked about spitting yet? No. So when you say decimal numbers, you have to spit a lot. Like 50 hundredths. If you don't spit, you're doing it wrong. It's not like 50 hundredths. No, you have to really emphasize the spit, or else you will get it wrong. You will fail if you don't spit. Yes.
There's a dollar sign near the $12.
Is it money?
That's not how
It's
you
money.
do that.
Okay, 12
Did you
bucks.
Did you just make a mistake?
Well, I didn't copy it down, so I'll count it as half a mistake. So if you catch me in another half clerical mistake, then I'll give you a free problem set. Okay? All right, number 11. What happens when you're missing something in a subtraction problem? Hands went up right away. Yes, Avery.
You add them. You add the two numbers that you have.
So in this case, you add, but it's not always the case, right?
Yeah.
What if you're missing the second number in a subtraction problem? What do you do, Grady?
You subtract.
It's another subtraction problem, okay? So here's my strategy. When it comes to addition and multiplication, it's always easy. You just do the opposite. But when it comes to subtraction and division, then try both ways and see which one makes more sense. So if I would have subtracted this, I would have gotten like 2,000 something, right? Then 2,000 something minus 4,000 something definitely does not equal 2,084. So that's not going to work. So addition is the answer. So we're going to add 2,007. Is it 84? 2,084 plus 4,782. Add them together. You get 6,866. Is that what you guys got?
Yep.
Okay, and then just plug it back in. You don't have to do the math again, but just make sure it makes sense. 6,000 something minus 4,000 something equals 2,000 something. Yeah, that makes sense. See how we did that? You're just ishing. Like 6,000-ish minus 4,000-ish equals 2,000-ish. Got it. Yes.
You can also just do it faster and turn the subtraction thing, like the symbol, and just make it
Yeah.
cross.
Yeah, you could just on that test you could just put a plus sign and do it. Yep. You don't have to make that noise, but you can do that. All right, number 12. What happens when you're missing something in a multiplication problem? What do? Marin.
You divide.
You divide. Remember, multiplication and addition is easy. When you're missing something, you always do the opposite. So 51.8 divided by 7. So $51.80. What happens when you divide with decimals? Do you have to worry about anything here? What do? Grace?
You just don't do anything, but you have to, for the answer, you bring the decimal up.
Yep, so decimal goes straight up. Now, if you were dividing by a decimal, remember you have to move that over. Did we talk about that yet?
No.
Okay, but we're not talking about it, so you don't have to be tested on that yet. So now we just divide normally. Dirty monkeys smell bad. How many times does 7 go into 5? Nothing, so go on to the next digit. How many times does it go into 51?
7 times.
7 times. Now, dirty monkeys, multiply. 7 times 7 is 49. Smell, subtract. Okay, bring down the next digit, which is 8. How many times does 7 go into 28? Hunter?
4.
4. 4 times 7 is 28. 0. Bring down the next digit, 0. How many times does 7 go into 0? 0. So you have to go to the end because of the money, right? So if it wasn't money, you could just say 7.4. But since it's money, I don't have $7.4. You kind of sound silly if you say that. You have $7.40. That's how cool people talk. I have $7.40. Seriously, that's probably all I have in my bank right now. There's a lot of expenses these days.
I don't even have that much. I have like 2 quarters.
Okay. We're more than half done. Feeling good? Feeling pretty? Oh, so pretty. Pretty.
You're staring at me. Stop.
Okay, number 13. I'm scrolling. Wrong way. Darn it. Okay, number 13. What happens when you're missing the second number in a subtraction problem? Avery?
You subtract 200.
Yes, that one.
Yeah.
Okay, so 1587, so 1,587 minus
Wait,
2,950.
that's number 15.
Of course it is. See, Kiara, if you would have caught me doing that, you would have free problems.
Don't compare me.
Wait, do I get a
So,
free
so
problem?
you get half of a free problem. Like if you get another, if you correct me again, so that's a clerical mistake. It's not a math mistake. Well, I mean, I guess you could argue that everything in life is mathematical. So we're going to subtract the minuend minus the difference, 2,532. So what do we get? Does that make sense? 6,000-ish minus 3,500-ish equals 2,500-ish. Yeah, that makes sense. Okay? So if I would have added that, I would have had like 8,000 something, and that would not have worked. So see how it helps, at least in your brain, to try both ways and see what works. Okay? Number 14. What happens when you're missing something in a multiplication problem? Divide, always divide. Unless you're missing the product, the answer, then just multiply. 270 divided by 15, dirty. Monkey smell bad. How many times does 15 go into 27? Just once. Multiply. Subtract. Bring down the next digit. How many times does 15 go into 120? Do you know?
8 times.
8 times?
It's still written wrong sheet.
All right, good job. 8 times 15 is 120 exactly. No remainder. You're good to go. Boom. Let's make sure it makes sense. Is 15 times, well, we just figured that out. 15 times 18 is 270. Yeah, that makes sense. All right, what happens when you're missing something in an addition problem?
It's subtraction.
Always subtraction. 2,950.
Mr. Flack,
Yes.
you said it was addition. It's subtraction.
No, that is an addition problem.
Well, I said, what happens when you're missing something in an addition problem? And you said it's subtraction. You almost caught me, didn't you? You thought you caught me, but you didn't. So you always subtract when you're missing something in an addition problem. So let's subtract the answer, the sum minus one of those addends, 1,587. We have to borrow a little bit. I'll pay you back.
Stealism.
Stealism? Is that a word?
My friend and I make up weird words.
Okay. You can get arrested for that in certain states. No, you can't. That's a lie. I lied. Sorry.
My mom and my brother watched your videos.
That's embarrassing. Okay. So let's just see if it makes sense. 1,500-ish plus 1,300-ish equals that. Yeah, that's about right. Okay, good. So you're kind of ishing it at the end just to make sure you did the right operation. Like you didn't add instead of subtract, or you didn't whatever. Okay? You guys good with those problems? All right, moving on to 16. 16. All right, we're multiplying 3 different things. What do you think would be a good thing to do to check your work here? Any suggestions? I mean, you could just do it twice and see if you get the same answer twice. What do you think would be good, Marin?
You could divide it.
Yeah, you could divide after you multiply it. You could divide by a number and then divide by the third number. That would work. What else could you do? I'm going to multiply this, and then you think about that. So what do you want to multiply first?
9 times 22.
9 times 22. I like to put the bigger digits on top. So, and it doesn't matter what order, right? So I can say 22 times 9. So 18, 19, so 198. Am I done?
No.
Okay, this is the biggest mistake of this problem. Guess what? You're going to think you're done and move on. Don't forget you still have another number to multiply. 25 Okay, 4,950. What's another way I could check this?
I know this way, but I bet it's not allowed.
Yes, Grace.
Instead of doing 9 times 22, you can do 22 times 25.
Yeah, you could switch the order. You could do 22 times 25 and then multiply by 9. And if you get the right answer, it's the same answer, then you probably did it right. Okay? Because that differentiates it enough to where it would be almost impossible to get the same answer if you did it wrong. Okay? Yes.
I have a question. Why are you holding 4 markers?
Oh, well, normally I like to do different colors to make it colorful, but I don't know.
It's a test. They're sad.
Black's just working for me right now. Good question. Is that the only thing you're paying attention to right now? Yeah. Okay. All right, number 17. All right, number 17 is 1,000 minus 720. Minus 38.
If my friend was here, she'd probably explode.
Is that better?
Yes.
Okay. Isn't it pretty? Does it make you want to eat Skittles? Okay, so what do you do first, Hunter?
Well, you gotta subtract the ones in parentheses.
Yes, do parentheses. Always P first. Okay? Always P first. So this one I'm not going to do anything with. I'm just going to leave it like here, and I'm going to put my answer to this problem right there. All right, so let's do that. 720 minus 38. So I need to borrow a little bit. So 682 is what I get there. Now I subtract. I'm going to kind of do it the faster way. I don't know. So this is 318. You could borrow if you want, but that's a lot of borrowing. And I always feel weird borrowing like from zeros. Doesn't that make you feel weird? Yeah. But you're really borrowing from this 1,000. But it's still like when I cross out a zero, I feel like I'm like making my own money. Doesn't that feel weird? Just makes me uncomfortable. Yes.
Isn't it supposed to be 684?
Is it?
No, it's 682.
Did I write it down wrong?
Problem wrong.
No, it's good.
No. Oh, did you write the problem down wrong?
I
720 minus.
Instead of 8.
Oh, 36. Okay. All right. Now, if you show your work, Hunter, I'll see that and notice that you wrote the problem down wrong, and I'm going to say, hey, he wrote the problem down wrong. I'm still going to give him credit. Okay? So that's a great reason to show your work. All right? All right. Number 18. So this is just a nice dirty monkey smell bad problem. It's always a problem when monkeys smell bad. 38,154. Okay. So start with the 3. 6 doesn't go into 3. How many times does 6 go into 38?
6.
6 times. Now multiply. 36. Subtract. Then bring down. And then rinse and repeat. How many times does 6 go into 21? Hunter?
3.
3. 3 times 6, 18. Subtract. Bring down. How many times does 6 go into 35? 5. Yeah, you can just shout it out now. 5 times 6 is 30. Subtract. 5. Bring down the 4. How many times 9 go into 6 go into
9.
goes in 9 times. Good job. 9 times 6 is 54. No remainder. You're done.
Thank you for shouting out the answer.
I know I did. Number 19. What does that mean when it's just 2 numbers next to each other and one of them's in parentheses? What does that mean?
Multiplication.
Multiplication. What is that? 150 times 18. Is that what that is?
Yep.
Okay. So you can set this up however you want. I do it this way. You can even hang that 0 off, but it doesn't really matter. 0, 40, 12, 0, 0, 5, 1. So did you guys get 2,700 for number 19? Awesome. Number 20.
This one's really easy.
All right, so far this test is looking pretty doable, right? Manageable. Okay, this is just another division problem. Anybody know the shortcut for dividing by 10? Grace, do you know it?
Move the decimal place.
You
to
just
the
move
left.
with the decimal
To the
one
right.
place to the left. But if you forget,
Oh yeah, just the left.
if you forget, you can always just do it normally. So I'm going to do it normally because I forgot. So how many times does 10 go into 41?
4 times.
4 times. Multiply, subtract, bring down 3. How many times does it go into
1.
13? Goes in 1 time. Subtract. How many times does it go into 30? 3 times. And then you're like, oh, that looks a lot like that. Just the decimal was over one place. Okay, what happens if you multiply a decimal number by 10? What happens, Kiara?
You made a mistake.
Did I?
You didn't put the dollar sign.
Oh, that's another clerical error. Good job. You got a free problem set. You got it. It was on the last problem. It's like the final stretch, and you made it.
I don't have to do problem set 8.
All right,
No,
you guys
I
good?
saved it.
Any questions with this test? Okay, and you can always rewatch this video if you're stuck on a question or two, but not while you're taking the test. When you're taking the test, you take the test. But yeah, you good? All right. Bye-bye now.
Black math. Give me some math and I'll give you some flack. Black math.